You know, all the time I have students ask me, Mr. Deulis, what keeps you so down to earth? And my answer is always the same: gravity. Speaking of gravity, we have this object here that is rolling off of some sort of platform, a table, or it could even be the top of a building. Whatever it might be, it is moving totally horizontally. It is going to roll off of this surface, and it is going to fall and is going to accelerate due to gravity. Keep in mind that this object would fall vertically at the same rate as any other object that is released from the same height. Okay, if this object here was to roll off of the edge, right, it's moving horizontally and it rolls off the edge, and at the exact same time another object is dropped from the exact same height at the exact same time, this object will fall and hit the ground at the exact same time that this object also hits the ground. They will have the same horizontal position at every single moment in time. So keep that in mind. And so with that in mind, as this thing rolls off of the, let's just say it's a table, as it rolls off of the table, it is going to take the same amount of time to hit the ground as an object that is simply dropped, because this object has no vertical velocity, right? It's moving only horizontally. And we're going to say that its horizontal velocity is 5 meters per second. So what we're going to do is we're going to determine how far from the edge, or the bottom edge of the table here, how far it is going to fall. And so here's a few things that we need to know. We need to know what the vertical height is. Okay, what is the vertical height? That is one thing that we're trying to determine. So this distance here, and I'm going to denote that as the distance in the y direction, okay, the vertical or y direction. And then what I also want to know is, and what ultimately I'm trying to figure out, is how far in the x direction it's going to go. And so I'm going to label that as the distance in the x direction, okay? So I want to know how far this thing is going to go before it hits the ground, okay? So it's going to go from here, and it's going to fall, it's going to follow a parabolic path, and it's going to hit the ground somewhere around here, and I want to know what that distance is. The distance in the x direction is what I'm ultimately trying to solve for. So what are the things that I have? And it's always good to write these things down. So the things that I have that are known is going to be the distance in the y direction. So I can physically measure the vertical height of the table, and doesn't matter too much to me as to exactly what the height is. Let's just kind of make up a number. Let's say that the distance in the y direction is, and let me actually kind of move this around a little bit. Let's say that this is equal to, let's just kind of give a nice number of 3 meters. Okay, so 3 meters is the vertical height that is moving, or excuse me, that it will fall. And the distance in the x direction is exactly what we're trying to solve for, so we don't know yet. That is still a question mark. Not the best question mark I've ever made, but you'll have to live with me. And of course, it's going to follow this sort of parabolic path towards the ground. Let's see, what else do we know? So we know that I'm just going to write all the knowns and unknowns here. So we have the distance and the y direction, that is equal to 3 meters. We know that the acceleration in the y direction, otherwise known as gravity, the acceleration of gravity is 9.8, but let's round that off to 10 meters per second squared. And then let's see what else we know. Oh, I don't know. We also know that we have this velocity that we've determined that it's rolling off of the table at a speed of 5 meters per second. So we know that the velocity, the initial velocity in the x direction, is equal to 5 meters per second. Now, I said that it's the initial velocity, but really the velocity in the x direction never changes, and that is a key point, that as this object moves through this parabolic path, its velocity in the horizontal or x direction never changes. The velocity in the vertical direction does change but we're not actually concerned about what its values are. We could figure that out, but we're not terribly concerned about that. We won't need it to determining the distance it goes in the x direction. Okay, so let's figure out how much time it takes for it to hit the ground. So for that, all we're concerned about is the distance in the y direction and the acceleration in the y direction. And from that, we can find the time. So what I'm going to say is that the distance is equal to 1/2 at squared. This is the distance in the y direction, therefore this must be the acceleration in the y direction. And here I have those values right here. I'm going to rearrange this equation to solve for time. So I'm going to multiply each side by 2. So 2d equals at squared. That gets rid of the 1/2. Okay, so 2d equals 1/2, 2d equals at squared. Now I'm going to divide each side by a. So 2d over a is equal to t squared. And then lastly, I'll take the square root of each side. So that means that t is equal to the square root of 2d over a, where this is the distance in the y direction and this is the acceleration in the y direction. In fact, oftentimes this is just expressed as just the lowercase g, which represents the acceleration of gravity specifically. In fact, you wouldn't even put this little subscript of the y with it because you know that it's in the vertical direction. So what is that value there? How much time does it take? So the numbers we're going to plug in are going to be, let's see, it's 2 times the distance in the y direction, that's the 3 meters. So 3 meters all over the 10 meters per second squared, and we'll take the square root of that when we're done. So let's figure out exactly what that value is. Right? Let's make this a little bigger and take a look-see at what this value is. Okay, turn this guy on. Let's get rolling. So I'm going to do everything inside of the radical first. Okay, so that's going to be 2 times 3. I'm going to hit enter, divide it by 10. That gives us 0.6, and then I'm going to take the square root. That's the same thing as going to the power of 0.5. And so it's going to take 0.7 seconds to go that vertical distance. Okay, so we have a time of, and let me shrink that down. So we have a time of 0.7, and you have to forgive me, I've got to look. 0.77 will work. 0.77 seconds was our time. So that's how much time it will take for it to hit the ground. That's the same time it would take for an object to just simply fall. So now that I have the amount of time it's going to take to hit the ground, now the rest of it is actually quite simple. So let me switch colors just so you can see that for the horizontal direction, I'm going to use an equation where the velocity in the x direction is equal to the distance in the x direction divided by the time it takes to get there. So to find the distance in the x direction, I'm going to simply take each side and multiply it by time. So the velocity in the x direction, which doesn't change, that velocity stays the same, times the time is equal to the distance in the x direction. So I'm going to take this velocity multiplied by this time, and that's it. That'll give me the distance that it goes. So let's multiply those two things together. Let's take a look at it again. Alright, so we have a velocity of 5 meters per second times a time of 0.77 seconds, and that gives us 3.85. Alright, so let's take a look at that. And 0.85. 0.85. And let's see, what are the units here? Well, let's take a look at it. In fact, let's write this out. Let me backtrack just a little bit. Okay, so let me write this out. So we have the velocity of 5 meters per second. In fact, let me write that differently. Let me write that a little bit differently. 5 meters for every 1 second. That's really what that is. Notice how seconds are in the denominator. Times the time of 0.77 seconds. So 0.77 seconds. Notice that this is actually in the numerator. That's the same thing as putting it over 1. This is in the denominator. So the seconds up top cancel with the seconds that are on the bottom, and I'm left with meters. So my answer is the 0.85 meters. That is my answer. So this distance in the x direction, it's not a question mark anymore. I now know that this is 0.85 meters. Okay? And so that's how we solve this problem. I would like to be able to kind of look back at this, but here's the main key point, is that the vertical direction and horizontal direction are completely independent of each other. That the vertical direction is what you use to determine how much time it's going to take to hit the ground, and then from that you can determine how far it will go before it hits the ground. So anytime you have any variable that is in the y direction, then every other variable within that equation has to be also in the y direction. For this one, this is the x direction. This also has to be the x direction. Every other variable has to be in the x direction except for one, time. Because time is the only thing that doesn't have a dimension to it. It doesn't exist in the 3 dimensions of space. So time is the one thing that can switch and translate from one equation to the other. It is the Rosetta Stone of all variables. It is able to translate from one equation to another, and it's the thing that all equations will have in common. So keep that in mind. The vertical and horizontal components are completely independent of each other. Gravity affects the vertical, not the horizontal, and I hope this helps, and you guys have a good one. I'll see you next time.